Welcome to Astronomy Daily. I'm so glad you're joining me today for another exciting look at what's happening in space and astronomy. We've got a packed show covering some fascinating developments across the space industry and beyond. Coming up, we'll dive into Boeing's ongoing challenges with their Starliner spacecraft program, where the company is facing some significant financial hurdles. We'll also explore an incredibly busy week in space launches, with multiple missions from SpaceX, Blue Origin, and Rocket Lab taking to the skies. Plus, we'll look at some groundbreaking research that's challenging what we know about planetary formation, examine the latest efforts in the search for extraterrestrial intelligence, and discuss growing concerns about space debris. There's a lot to cover today, so let's jump right in. Boeing's financial struggles with their CST-100 Starliner program have reached new heights, with the aerospace giant reporting staggering losses of $523 million in 2024 alone. This marks the largest single-year loss for the commercial crew vehicle program to date, pushing the total program losses beyond the $2 billion mark. According to Boeing's recent SEC filing, these mounting costs stem from a combination of schedule delays, increased testing and certification requirements, and higher expenses for post-certification missions. The company had already disclosed significant charges throughout the year, with $125 million in the second quarter and $250 million in the third quarter, before adding another $148 million loss in the final quarter. The situation appears far from resolved, with Boeing explicitly warning that additional losses might be on the horizon. Neither Boeing nor NASA has provided clear timelines for Starliner's next flight, leaving questions about whether the next mission will be crewed or uncrewed. NASA's Aerospace Safety Advisory Panel recently reported some progress in addressing certain issues with the spacecraft. However, the thruster problems that led NASA to bring the last test flight back uncrewed remain unresolved. While panel members expressed confidence that NASA is focusing on the right core issues for safely flying Starliner, the path forward remains uncertain. This ongoing saga represents a significant challenge for Boeing's space division and raises important questions about the future of commercial crew transportation to the International Space Station. The financial impact of these setbacks continues to mount, highlighting the complex nature of developing and certifying new spacecraft for human spaceflight. Let's turn our attention to launches. This week marks an exceptionally busy period in spaceflight, with multiple launches scheduled across several commercial space companies and government agencies. The diverse lineup showcases just how vibrant and competitive the modern space launch industry has become. Rocket Lab is preparing for their first mission of the year from New Zealand, aiming to launch 5 nanosatellites for French company Kinéis aboard their Electron rocket. These satellites will enhance global Internet of Things connectivity, demonstrating how space technology continues to improve our daily lives here on Earth. Blue Origin's New Shepard suborbital rocket is set for an innovative mission that will simulate lunar gravity conditions. The flight will carry 30 payloads, including 17 from NASA, providing researchers with precious minutes of lunar gravity conditions to test technologies crucial for future moon missions. This is achieved through a clever method of spinning the capsule at precisely 11 revolutions per minute, creating an environment that mimics the moon's gravitational pull. SpaceX continues their ambitious launch schedule with 4 Falcon 9 missions planned this week alone. 2 of these launches will deploy Starlink satellites, including special direct-to-cell capable units that will expand their communications network. Another mission will carry WorldView Legion Earth observation satellites for Maxar Technologies, capable of monitoring changes on our planet's surface with remarkable 30-centimeter resolution. Meanwhile, Russia is preparing to return to flight operations with their first Soyuz launch of 2025, carrying classified satellites to orbit. This mission from the Plesetsk Cosmodrome demonstrates that despite geopolitical tensions, space operations continue across all major spacefaring nations. These launches represent more than just individual missions. They showcase the transformation of space access from a purely government-driven endeavor to a dynamic commercial marketplace. With multiple providers offering various launch services, we're witnessing an era where access to space has become more routine and diverse than ever before. And in some not-so-good news today, India's first space mission of 2025 has encountered significant challenges, highlighting the complex nature of satellite deployment operations. The mission, which marked the 100th launch from India's historic Satish Dhawan Space Center, initially appeared to proceed according to plan, with the successful liftoff of their geosynchronous satellite launch vehicle. The spacecraft, designated NVS-02, was intended to join India's navigation with Indian Constellation Network, known as Navi-C. This system provides crucial positioning, navigation, and timing services for India and surrounding regions, similar to the GPS system we're all familiar with. However, the mission hit a snag during a critical phase of deployment. After reaching its initial transfer orbit, the satellite experienced a valve issue that prevented it from firing its engines. This malfunction has left the spacecraft stranded in an elliptical transfer orbit, rather than reaching its intended position in geostationary orbit, approximately 22,236 miles above Earth's equator. The Indian Space Research Organization isn't giving up on the mission just yet. Engineers are currently exploring alternative solutions, including the possibility of using the satellite's smaller attitude control thrusters to gradually raise its orbit. While these thrusters weren't designed for major orbital adjustments, they might provide enough thrust to prevent the satellite from eventually falling back to Earth due to atmospheric drag. Despite this setback, ISRO reports that the satellite's other systems remain healthy, and they're actively working on developing alternate mission strategies that could still allow the spacecraft to provide navigation services, albeit from its current elliptical orbit. This situation demonstrates both the challenges of space operations and the ingenuity required to adapt when things don't go as planned. In a remarkable demonstration of our ongoing search for extraterrestrial intelligence, scientists have recently completed one of the largest SETI experiments ever conducted, examining data from nearly 1 million cosmic objects. Using a powerful new system called COSMIC, which stands for Commensal Open Source Multi-Mode Interferometer Cluster, researchers have pushed the boundaries of our search capabilities. Working in conjunction with the Carl G. Jansky Very Large Array, COSMIC processes an enormous amount of astronomical data, specifically looking for signals that might indicate artificial radio emissions from distant civilizations. The system's sophisticated algorithms are designed to identify narrow band signals that change frequency over time due to the Doppler effect, characteristics we'd expect to see in artificial transmissions from advanced civilizations. While the search through these 950,000 objects hasn't detected any clear signs of extraterrestrial intelligence, it represents a significant milestone in our systematic exploration of the cosmos. The project's real achievement lies in demonstrating the effectiveness of new automated processing systems that can handle the overwhelming volume of data modern astronomy generates. The elegance of COSMIC's design allows it to operate alongside regular astronomical observations, essentially piggybacking on existing research to conduct its SETI analysis. This approach maximizes the efficiency of our search efforts while making use of every available moment of telescope time. In a rigorous test of the system's capabilities, researchers focused on a subset of 511 stars from the Gaia catalog during a 30-minute observation window. Though no potential technosignatures were identified, this test proved the viability of COSMIC's rapid filtering mechanism, paving the way for even faster and more automated searches in the future. This project marks an important step forward in our quest to answer one of humanity's most profound questions. Are we alone in the universe? While we haven't found anyone out there yet, we're now better equipped than ever to continue the search, processing more data from more potential sources than ever before possible. We seem to have talked about this problem a lot. Now it's getting serious. The growing issue of space debris poses an increasingly significant risk to aviation safety, with new research highlighting the concerning intersection between falling space objects and aircraft operations. A recent study published in Scientific Reports reveals that there's a 26% annual chance of uncontrolled space debris re-entering Earth's atmosphere over busy airspaces like Northern Europe or the northeastern United States. This risk was dramatically illustrated during SpaceX's recent Starship test flight, where the Federal Aviation Administration had to activate a debris response area and adjust flight patterns to protect aircraft from potential falling debris. Several planes were forced to divert due to fuel concerns while holding outside the impacted areas. The challenge is becoming more complex due to two converging factors: the increasing frequency of space debris reentries, and the growing volume of airline traffic. National authorities now face a difficult choice between closing airspace during reentry events, which carries significant economic and logistical consequences, or accepting the small but potentially catastrophic risk of collision. Making matters more challenging, over 2,300 rocket bodies currently orbit Earth, all of which will eventually re-enter our atmosphere in an uncontrolled manner. While the probability of an aircraft strike remains relatively low, the potential consequences could be devastating. The situation creates a complex dilemma for aviation authorities, who must balance safety concerns against economic impacts. While controlled re-entries into ocean areas could help mitigate these risks for future missions, the existing debris in orbit means this challenge will persist for decades to come. This growing problem underscores the urgent need for better space traffic management and more controlled disposal methods for space hardware. In a fascinating development that's challenging our understanding of planetary formation, astronomers studying the ultra-hot Jupiter WASP 121b have made some unexpected discoveries about this extraordinary world. Located about 858 light-years from Earth, this peculiar planet has earned the nickname roasting marshmallow due to its extreme temperatures and puffy appearance. WASP 121b is truly a remarkable object. While it only has about 1.2 times the mass of Jupiter, it's actually nearly twice as wide, making it one of the puffiest planets we've ever discovered. It orbits incredibly close to its star, completing a full circuit in just 1.3 Earth days, and is tidally locked, meaning one side perpetually faces its star while the other remains in darkness. The day side of this world is almost unimaginably hot, reaching temperatures of around 4,500 degrees Fahrenheit. That's hot enough to vaporize metals, which then get caught in powerful 11,000-mile-per-hour winds that carry them to the cooler night side. There, these metals cool and fall as exotic rain, not water drops, but liquid metal, ruby, and sapphire. But here's where things get really interesting. Using the Gemini South Telescope's IGRINS instrument, researchers have found evidence suggesting that WASP 121b may have actually formed very close to its star, contrary to our traditional understanding of how gas giants develop. The planet's unusually high rock-to-ice ratio indicates it accumulated a substantial amount of rocky material during its formation, something that should only happen in the hotter regions close to a star. This discovery challenges our current models of planetary formation, which suggest that gas giants need solid ices to form and typically develop much further out from their stars before migrating inward. The research team is now planning to study more ultra-hot Jupiters to determine if WASP 121b is a unique case, or if we need to fundamentally revise our understanding of how these extreme worlds come to be. And that wraps up another fascinating episode of Astronomy Daily. From Boeing's ongoing Starliner challenges to the mysteries of ultra-hot Jupiters, it's been another incredible day in space science and exploration. I'm Anna, and I've loved sharing these stories with you today. If you want to stay up to date with all the latest developments in space exploration and astronomy, head over to astronomydaily.io. There you'll find our continuously updating newsfeed, bringing you the freshest space news as it happens. While you're there, don't forget to sign up for our free daily newsletter to get all these stories delivered straight to your inbox. You can also dive into our extensive archive of past episodes, perfect for catching up on any space news you might have missed. And remember, our community extends beyond just our website. You can find and follow Astro Daily Pod on Facebook, X, YouTube Music, Tumblr, and TikTok. Come join our growing community of space enthusiasts and be part of the conversation. Until next time, keep looking up and stay curious about the cosmos. This has been Astronomy Daily. Thanks for listening.